Hi everyone, this is Sahil from QuickNode, and today in this video we will learn about the ERC777 fungible token standard. We will also create and deploy a ERC777 token smart contract. So without any ado, let's jump into it. ERC777 is a new token standard which lets you do a lot more with your tokens as compared to just transferring or minting your tokens in ERC20. And it won't break your already live and deployed ERC20 smart contracts because it's backward compatible with ERC20 contracts. So some of the major features are as follows. The first one is hooks. So hooks are basically a way to add custom logic or custom execution during sending or receiving your tokens. Once you implement hook, you can implement logic while sending tokens by implementing tokens to send function, and you can also implement some execution logic whenever a token is received by implementing token receives function or token received hook. So these hooks needs to be implemented in a smart contract, and then that smart contract needs to be registered with the ERC1820 registry. So ERC1820 registry keeps track of hooks associated with a address or associated with a contract. And then comes operators. Operators are basically addresses which you can authorize to spend or transfer tokens in place of you. So operators can do that by using two functions, operator send or operator burn. Operator send is basically an operator who is authorized to spend tokens or transfer tokens can send token on your behalf, and operator burn can just burn token, which basically means send token to a zero address. So operators can be defined while creating or deploying your contract, which are default operators. Any token holders can define new operators or can revoke older operators whenever they want using the token smart contract. Anyone can check if an address is an operator or not by using isOperator for function of that particular token contract. And all of the ERC777 contracts or tokens are backward compatible with ERC20, where in ERC20 you used to use transfer just to transfer tokens, or transfer from, where a smart contract who was approved to spend tokens in place of you or for you would use transfer from. But in the case of ERC777, you do not have that confusion. You just have send or operator send, where you can authorize a smart contract or another address to be an operator for you so that they can send tokens on behalf of you. And that being said, all of the functions of ERC20 can be implemented in an ERC777 smart contract as well, side by side. So all of these improve the overall user experience of fungible tokens. So now let's create and deploy our ERC777 smart contract, and we will be using Foundry to do that. So make sure you have Foundry installed on your computer, and if you do not know how to do that, I will have a Foundry guide link in the description below. So once you have initialized your Foundry project, install the OpenZeppelin smart contracts library, because we will be using OpenZeppelin library or contracts library to create our ERC777 smart contract. So let's do that first. And once that's done, let's open the project in a code editor. Now create a new file called remappings.txt and paste this in your file. So we are basically telling our Foundry project that use this to access the contracts available at library OpenZeppelin contracts. So we are just basically adding remappings to this particular path to this so that we can use it in our contracts. Now the next thing would be to add our QuickNode RPC URL and private key to the particular project so that we can use that private key to deploy our smart contract or sign the transactions for our smart contract, and use the RPC URL to transmit that transaction. And what we will do is we won't save any of the sensitive information in an environment variable. You could do that, but it's not ideal always. So what we will do is we will write this command, export RPC URL is equal to our actual RPC URL, and then export private key is equal to our actual private key on the command line, so that those particular environment variables are live or valid for that particular session whenever you are using Foundry. So while following the tutorial, make sure to replace this, your RPC endpoint, with your actual Sepolia RPC endpoint, which you can get from your QuickNode dashboard once you have signed in and created your Sepolia endpoint or Ethereum Sepolia endpoint, and your private key will be your Ethereum private key or Ethereum Sepolia private key. And make sure to have some Sepolia ETH, which will be required to pay for the gas. And if you do not have any testnet ETH on Sepolia, you can get it from faucet.quicknode.com. And once you have added your environment variables to the command line, just go to SRC directory and create a new file called test ERC777.sol. So this will be our ERC777 smart contract. And as you can see, we are using the OpenZeppelin contracts library to import the ERC777 smart contract of OpenZeppelin, which are already tested and audited. And in this smart contract, we are basically starting our contract called ERC777 or test ERC777, and we are saying that it is using the interface ERC777 of OpenZeppelin contract, starting the constructor with name, symbol, address, and also default operators. And then we have a function mint, which will have account, amount, and some user data and some operator data. So after this, what we will need to do is we'll need to create a recipient smart contract to test the hook functionality of ERC777. What this recipient smart contract will do is, it will basically implement the token received hook, and once that hook is triggered, it will override the current state of the smart contract and change the received tokens amount, last received amount, which will be the transfer amount of the last transaction, and the last operator's address, and also the last sender's address. So it will note down all of these and emit it in an event called token received. And it also has some public functions, get received tokens, which will get all of the received tokens, as you can see over here. And it has another function, get last received information, which will get the last received amount and last operator's address and last sender's address. In this smart contract, we are importing the ERC777 recipient.sol interface of OpenZeppelin contracts, and we are creating a new smart contract, test ERC777 recipient, which is inheriting the ERC777 recipient contract. And because the smart contract is using or will be using hooks, we will have to register it with ERC1820 registry. So that's why we are also importing the ERC1820 registry.sol interface of OpenZeppelin contracts. And now let's go to test the functionality of this smart contract along with the actual ERC777 smart contract which we created over here. So go to test, create a new file, test ERC777.t.sol, and this is how our test file will look like. So what we are basically doing over here is we are importing the test.file of Foundry, which is required to write test in Foundry. And then we are importing the ERC777.sol and ERC1820 registry.sol of OpenZeppelin so that we can use their functionalities. And we are also importing the ERC777.sol contract, which we just wrote over here, and the recipient smart contract, which we wrote over here. And then we are initializing this contract called ERC777 setup.test and saying that it will be using the test interface of Foundry. We are initializing the ERC777 and recipient smart contracts over here. And then we have a setup function which will initialize the environment or test environment for our contracts test, where we have a mock registry or mock ERC1820 registry with the bytecode over here. And then we are initializing a sender and operator address. Then we are deploying the ERC777 token contract and ERC777 recipient contract. And after that, we have another function, test ERC777 setup, to test the setup which we did in the setup function, where we will verify the registry is deployed, we will verify ERC777 token is deployed, we will check the token details, and we will mint some tokens to user 1, which is the first wallet address, and then we will check the balance. Then we have test ERC777 transfer to address function to test the transfer functionality of the smart contracts, where we will mint few tokens to the user 1 address, and then user 1 sends some token to user 2, and then we will print their balances. And yes, this test script is long, so don't worry about that. This script, along with all the other scripts and contracts, will be available in the guide linked below. So after that, we will have another function called test ERC777 transfer to registered recipients, where we will test the transfer hook or send hook, where first again we will mint some tokens to user 1, then the recipient contract will be registered with the registry, and then the user 1 will send some tokens to the recipient contract, and the recipient contract state will be updated and following values will be logged, and then the balance will be checked again for both the user 1 and recipient smart contract. And then we have another function to test the operator send functionality, where the user 1 will mint some tokens again, and user 2 will be set as an operator for user 1. Then we will check if the recipient smart contract is properly registered with the registry or not, and then the user 2, which we just set as the operator for user 1, will send some tokens from user 1's account to the recipient contract, and then check the recipient contract's state again and get the values again, and then again check the token balances. So this is how our test file looks like, and now let's test it. So the contracts are compiling, and as you can see, all of our tests which we just saw have been passed. So once our tests have been passed, what we need to do is we will need to write a deploying script. So the deploying script will go under the script directory, and we will name our file deploy ERC777 contracts.s.sol, and the script will look like this. And what we are doing over here is we are importing the script.sol interface of Foundry so that we can use this particular contract as a script, and then we are importing the ERC777 contract and ERC777 recipient contract. We are initializing this particular contract as a script, which will use the script interface of Foundry, and then we are initializing a new variable with the ERC1820 registry's address, and we are saying that the recipient smart contract will be registered with the registry. And then we have two deployment functions for our ERC777 smart contract and ERC777 recipient smart contract. So what we are basically doing is we are broadcasting the transaction and sending the smart contract to the Sepolia testnet, and the initial supply will be 1 million tokens with 18 decimals. You do not need to implement decimals in ERC777, but if you are implementing decimals, they have to be 18. And then we are saying that the name will be gold, symbol will be GLD, and we are minting the token along with default operators. So you can set your default operators over here, and we are minting the tokens to our wallet address, which will be the wallet address from which the transaction will be sent. And then we are stopping the broadcast and logging some messages to the console, where we will be printing the address of the token, we will be printing the address of the deployer, and we will also print the initial supply. In the deploy ERC777 recipient function, what we are basically doing is we are deploying the ERC777 recipient smart contract and then printing some information that will be the recipient contract's address and the registry's address. So now to deploy the contract, our command will be forge script deploy ERC777 contracts.s.sol. So we are basically saying that use this script and then use this constructor, and we are saying that use this function which will be deploy test ERC777, which is our token smart contract. And we are saying that use the RPC URL from environment variable, which is RPC_URL, and then broadcast the transaction, and use the private key, which is again in the environment variable, which is private_key. So let's run this. As you can see, the compilation is successful. And these are the log messages which we had over here. Let's go back. So as you can see, the transactions are still pending. Now the transactions are successful. The first transaction is for contract deployment and the second transaction is for token minting. Now let's take a look at the transactions in Etherscan. So let's go to sepolia.etherscan.io and paste the transaction hash. So as you can see, this was the transaction of contract creation. This will be our token smart contract. And if we go back to our terminal, get this address, look for it, so you will see that it was for minting this token. And similarly, to deploy the recipient smart contract, what you'll need to do is you'll just need to replace this function with this function so that your recipient smart contract can be deployed as well. So the command will look something like this, and once you run it, as you can see, the transaction is going through. It's in the pending state right now. So now that our transaction is completed, our recipient smart contract is deployed as well. So now let's take a look at the recipient smart contract in Etherscan. So this is our recipient smart contract. Now if we send some tokens to our recipient smart contract, it should update the state of the recipient smart contract and emit an event. So let's do that. So now that the transaction is completed, let's refresh this. The transaction is complete. The token received hook must have been triggered and this event was emitted. As you can see in the recipient contract, this event was emitted along with these details like the operator address, from address, to address, amount, user data, and operator data. And if we were to get these details which were logged, we would have to call these functions. So as you can see, these are the emitted data with the event. So this is how you can create and deploy ERC777 smart contracts and use hooks to implement custom execution logic while sending or receiving tokens. So if you learned anything from this video, make sure to hit the like button, subscribe to the QuickNode YouTube channel, and I'll see you in the next one. Bye bye.